Well, hello, AP Calculus. Here we go. Today we are going to talk more about some other integration techniques. Before we get started into the brand new stuff, let's see if we can sort of jog your memory. We'll call this a warm-up. And we'll say number one, the integral of dx over x squared minus 4x plus 5. All right, so some of you guys might be looking at this problem and thinking, "Ooh, it has to be a natural log. I have my x in the denominator." To which someone is like, nope, because there's no 2x minus 4 up top to do a u sub. So we're going to think again. Think about stuff we did when we were together in class. And what we're going to do here is we're actually going to try to rewrite the bottom. Okay, and when we go to rewrite the bottom, some of you might be thinking, oh, I want to jump straight to factoring. So in fact, this guy can't factor. So we're going to rewrite the bottom by what method? Does anyone remember? I think you're thinking of it. We're going to complete the square. Okay? And remember that I can rewrite this as, if I complete the square, x squared minus 4x plus blank. Move the 5 over, minus blank. And when we go to fill in the blank, remember it's b over 2 squared. In this case, our b is the negative 4, right here. That guy, that's our b. So when I take b divided by 2, I get negative 2. When I square it, I get 4. Boop, boop, right here. Okay, so that is dx over, I'm now going to write that as x minus 1 quantity squared plus 1. The integral of this, and you should be saying, oh my gosh, yes, I remember this. This is going to be the inverse tangent of x minus 2. Add our constant, pretty little box, call it a day. Okay? So this is one where we complete the square, and the key thing, as you remember from inverse tan, is we have to have the a squared plus u squared. This part right here, it needs to be a plus something. All right? So what happens if we have a question like this now? Number 2, I'm going to give you the integral of dx over x squared minus 6x plus 5. Okay? And you're going to see here that when we do this problem, okay, we're not going to complete the square because completing the square doesn't help us. Okay? So what we can do is you're going to think, oh, wait a minute, this factors. All right? And you're right, this does factor. This is the same thing as the integral of dx over x minus 5 and x minus 1. Okay? But factoring it here, okay, there's no integral facts that allow us to integrate this as is. So what we have to do is we have to break down this fraction. So what we're going to do is we're going to decompose it. And this is called partial fraction decomposition. So that's the strategy we're talking about today. Partial fractions. Whew. All right. The way we decompose partial fractions is we are going to sort of undo getting that common denominator. So I'm going to take my fraction. I'm going to say, okay, there's some numerator, a, that I can put over x minus 5. And there's some numerator b that I'll put over x minus 1. And when I add these fractions together, okay, normally I would cross multiply, get the common denominator. That would bring us right back up to what our original problem was up here. Okay, this guy. But we're separating it right now. And so what we're going to do is we are going to say, okay, if I separate it, let's find what A and B have to be in order to get that to be our single fraction. And the way we do that is, any guesses? What are you thinking? I I think I heard a cross multiply. I think I did. So we're going to cross multiply. When we do that, I'm going to get a times x minus 1. And I'm going to break this down slowly for you. And we're going to have b times x minus 5. And the key thing is that happens to equal our numerator from the original problem. Okay, this numerator up here. Now really, I'm not going to write dx. I'm just going to say 1. Okay, because it's 1 dx. Now, that gives me 1 equals, I have ax minus a plus bx minus 5b equals 1. We are going to take everything that has an x and put it together, and everything that does not have an x, and we are going to combine those together. Okay, so the other way you could think about it is if you wanted to, I could have written on this side plus 0x. Okay, because there's no x in my numerator. So underlining that guy, all the purples. So taking all the purple, I'm now going to say I have ax plus bx equals 0x. Or really we can just say a plus b equals 0. Over here with my yellow, I would have negative a minus 5b equals 1. So what we have, ladies and gentlemen, is I have 2 equations with 2 unknowns. And what does that make? A system of equations. So I'm going to go to the next page because I'm sort of running out of room here. And we're going to take a plus b equals 0. And then we said negative a minus 5b equals 1. Okay? Here, think about the ways you can solve systems. Substitution, elimination. Technically, we can do graphing. My personal favorite is always elimination. Always. And if you look right here, we already have the A's being opposites. So I'm just going to go ahead and add these together. And I'm going to get that negative 4b equals 1. Thus, b is negative 1/4. And then if you remember anything about systems, we're going to take this guy and we're going to plug them in. Okay, I'm going to go up here to that top one because it's nice and easy. And say a minus 1/4 equals 0. And that means a must be positive 1/4. Okay, so you're probably thinking, great, fantastic, we have to be done already, right? No, not at all. Because what we have to do is we now have to go back to our integral. So what we're saying is the integral of 1 over x squared minus 6x plus 5 is actually the exact same thing as the integral of 1/4 over x minus 5 plus, and we can now say the integral of negative 1/4 over x minus 1, all of this with a dx, of course. Okay? So hopefully that's helpful in terms of where we got the 1/4 and the negative 1/4. If you have questions, please write them down so we can ask each other when we see each other again. All we did was rewrite the integral. We still have to evaluate the integral. So from here, moving on now to the next page, we're going to have 1/4. When you take the antiderivative of essentially dx over x minus 5, bring in our natural log here. And then we have a negative 1/4 natural log absolute value of x minus 1. Don't forget your constant. And just to make sure you're comfortable with your log rules, that is the same thing as 1/4 the natural log of the absolute value of. When you divide like bases, okay, what do you do to the logs? Well, I always call it the guts of the logarithm because it's the inside of the log. Oh shoot, I think I said it wrong. I think I said divide earlier. Oh, shucks. When you subtract like bases of logarithms, you divide the guts. Oh, man. I'm not going to stop this recording and start all over just because I spoke that wrong. That's okay. You guys can just laugh at me and make fun of me later. But yes, when you subtract logs of the same base, you divide the guts. And that's our final answer. Okay? But fun fact, if you remember, we told you this before the AP exam, you don't have to simplify. So both of these answers totally work. Either one. All right? And that is example 2. All right, let's go again here. Okay, we're going to go with 3. We'll do 3 together, and that's the integral of dx over x squared plus 2x minus 8. And again, step 1, what do? We have to factor. So we factor this guy, and we get x squared. Oops, I lied. I'm just going to jump straight to factoring, not rewriting and showing you all that. My apologies. That's x plus 4 and x minus 2. So now we have to actually solve and decompose these fractions. Remember, you're going to put a over one factor, b over another factor, and yes, you would still keep going. If we had a third factor, we'd put c, and so on. Okay? We would cross multiply again. So I'm going to go ahead and distribute the a here. I like to think that we can handle that. Ax minus 2a plus bx plus 4b. And again, what is happening is this guy equals, all right, my numerator up here, which in this case, again, is just 1. Put all the x's equal to each other, okay? So as a reminder, I have ax, I have bx. There's no x's over there. So I'm going to say a plus b equals 0 again. I'm now going to take the non-x's, put them together. So I have negative 2a plus 4b, and that's going to equal 1. And now we have our system here. And this one is not set up where we can just go ahead and add them together and eliminate a variable right now. We got to do a little extra work. What is that extra work that I need to do? Well, if you go ahead and take this top guy and chase an a through there, oh my gosh, chase a 2 through there, we would have 2a plus 2b equaling still 0, and 2a plus 4b equaling 1. Oh my goodness, I'm getting ahead of myself. All right, and then when we go ahead and add these equations together, we would get that 6b equals 1. Thus, b has to be 1/6. And if b is 1/6, then what does that make a? I'm giving you a second to think about it. Hopefully you're saying it's negative 1/6. Just want to say, awesome! And we come to our integral now. And we're going to rewrite it as negative 1/6 over x plus 4. And then we're going to have positive 1/6 over x minus 2. We're going to integrate this guy, and we get 1/6, the natural log of the absolute value of x plus 4, adding the 1/6 natural log of the absolute value of x minus 2. Don't forget your constant. Now, to combine these guys, what you got to be careful of is your negative ones out front. So if you were to rewrite this as a logarithm, you would have the natural log of the absolute value of the positive natural log is what would be on top. The x plus 4 would be in the bottom, and yes, you would still have the 1/6 out front. Okay? So, any questions here? jot them down, save them for when we see each other again, and we can go over this. But again, what we're doing is we're decomposing the fraction, okay, and then we're integrating. It allows us to separate one fraction into two so we can integrate them separately. All right, so what I'm going to do now is I'm going to give you guys a wow, that was not a good circle. The integral of dx over 2x squared plus 5x minus 3. Okay, and I'm going to give you 5, which is the integral of 3x minus 2 over x to the third minus 7x squared plus 10x dx. And these are going to be your you-dos. So what I want you to do is I want you to pause the video, okay? I want you to try these on your own and then come back. We're going to go over them together, and then we're going to do one sort of challenge one to end it for the day. All right, take a second, try what you can do, and then we'll come back and check our answers. Okay, hopefully you've had a chance to work on these a little bit. I went ahead and factored number 4 because that's the one we're going to go for first. If you were to do the partial fraction portion, hopefully you got that A was 2 over 7 and B is negative 1 over 7. And when you go to get your answer or to integrate here, you would have gotten 2 over 7 over 2x minus 1 plus the integral of negative 1 over 7 over x plus 3. Still with our dx's. Oh, goodness. If you hear my dog, I'm sorry. Okay, so we're here. This is going to give us, be careful. Because what's going to happen, you're actually going to get 1/7 the natural log of the absolute value of 2x minus 1. And then you're going to get negative 1/7 natural log of the absolute value of x plus 3 as your constant here. Okay? And you might be wondering, where did that 1/7 come from? Okay? But keep in mind, if you have to do and account for this too, so it still would be like a u sub of 2x minus 1. And we have the 2 in the numerator, technically, so just keep that in mind. Okay? This guy over here, number 5, okay? When you factor this one, you get x, because you got to take out the GCF first. Make your algebra teachers proud. X minus 5, x minus 2. So notice here, in this case, we have 3 factors. So when you solve this, you're going to have an A, a B, and a C. Did you set it up that way? What you end up with is A is negative 1. Hello, stylist. Cooperate, please. Negative 1/5 over x. I feel like I need to make sure to have a marker down here. There we go. Plus, I got 13/15 over x minus 5. And then I got negative 2/3 over x minus 2. And of course, we're integrating this. And you can draw separate integrals for each one if you like, or one big integral. It's fine. Okay, but we're integrating this guy. There's supposed to be a dx in there. Yeah, I just can't fit it in. Okay, so here we go. Solution, negative 1/5 natural log of the absolute value of x plus 13/15 natural log of the absolute value of x minus 5 minus 2/3 natural log of the absolute value of x minus 2. Add your constant. Sorry, I ran out of room. I probably should have written these separately, but I tried to make it fit on one screen for you all. Okay? Those were your you-dos. Let's talk about this one really cool question. Your assignment for partial fractions out of the textbook does not have any that are going to be like this challenge one. They're all going to be like questions 2 through 5, okay? But when we see each other again, you can certainly ask me any questions that you have on this, okay? But question 6, it's a doozy. We're going to go 6x squared. That already makes it fun with the x squared up the top. Over x to the third minus 4x squared plus 4x. Okay, so you're probably thinking, all right, I know I have to take out the GCF. And I'm going to say, ding, ding, ding. Yes, you do. When we go to factor this guy factors to be, take out that x first, and you're left with this. And then you're probably thinking, okay, well, that's just x minus 2 and x minus 2. And you're 100% correct. And here's where it gets interesting, because what you have to do is you're like, all right, I'm going to have an A, a B, and a C. I have 3 factors. And you are exactly correct. You are going to have an A, B, and the C. And you're going to have A over x, and you're going to have B over x minus. Okay, let's try again. Oh, hello. Go back to this. B over x minus 2. And then what's different is what C has to be. Because so many people think C needs to be x minus 2. Okay, because that's the third factor. But here's the thing. That doesn't make C any different than what B is right now. Because the reality is when you have the same factor occurring twice, you have to account for the fact that it can occur twice by squaring that. Okay, so you need to square that term because you have x minus 2 and then you have x minus 2 squared. Because the reality is this B portion may or may not be there every time. All right, so you have to account for all possible factors in your denominator. Okay, so now we're going to set this guy up and we're going to solve here. And again, we're still going to do the same thing. You're still going to solve by solving for that common denominator. We're going to say, okay, I'm going to come down here that we're going to have the numerator, the 6x squared minus 3x plus 1. And that's going to equal, okay, this A needs this factor. So it's going to be A times, you can say x squared minus 4x plus 4. Then we're going to have B, and B already has an x minus 2. You don't have to multiply by the x minus 2 squared. In order to get the common denominator that we have over here, this is our common denominator right there. That's what we're trying to get to. So B already has x minus 2. I need the x, and I need another x minus 2. And C only needs the x. He already has the x minus 2. So hopefully we're doing all right here. Then what we're going to do is we're going to say, all right, I got ax squared minus 4ax plus 4a plus bx squared minus 2bx plus cx. And that's going to still equal this guy. So when we go to set up what we have matching, what equals each other, we are still going to take, okay, my x squared. There's no c squared, so I have that 6 is going to equal a plus b. Then we're going to take our x's. And I'm going to say I have negative 4a minus 2b plus c, and that's going to equal negative 3. And we're going to get a third color here now, and we're going to say 1 equals, the only thing that's left is 4a. So we have 4a equals 1. So right away we can say that a is 1/4. We can plug this in to our purple equation, and that's going to give us that b is 6 minus 1/4, or that B would be 23/4. And lastly, we will take B and A, plug them into the green equation, and C ends up being 19/2. So then what we do is we rewrite our integral, and we get the integral of 1/4 over x plus 23/4 over x minus 2 plus 19/2 over x minus 2 whoop whoop squared dx for our final answer of 1/4. The natural log of the absolute value of x plus 23/4. The natural log of the absolute value of x minus 2 plus 19. Hello, stylist, come back to me. 19/2, the natural log of the absolute value. Okay. Oh my gosh, I got carried away because that's so not right. What is it, guys? And you might be thinking, Ms. Gutierrez, you did that on purpose, and you'll never know if I did or didn't. But what is it? Because it's not a natural log. It's a u to the negative 2, which actually makes it negative 19 over 2 u. Why is my stylus not work? There we go. X minus 2 to the negative 1. And then add your constant. Yes, you can 100% totally write that as negative 19 over 2 times the quantity of x minus 2. Same thing. Doesn't matter. That's a super cool, challenging one. I hope you enjoyed learning about partial fraction decomposition and integrating using the technique of partial fractions. Okay, we are going to talk more about this next time I see you. There's a problem set that is going to be on Canvas for you. It is page 369, numbers 6, 10, 12, 14, 20, and 22. Again, none of those have the extra factor squared and counting and relying on the repeating factors. But that's just a really cool thing that we just did with the challenge one. So, hope you guys have an awesome day. Can't wait to see you soon. Miss you.